My name is Brandon Haynes, and on behalf of my co-author Charles Lee, I'm here to discuss internet worm simulation using MapReduce. So worms exploit a widespread vulnerability in internet-connected machines, and they're distinguished from viruses due to their automatic propagation. There have been a handful of high-profile infections over the last decade, with damages in the billions. And so this worm propagation thing has been well researched, but historically has been formulaic in nature. By contrast, our work looks to model this propagation via simulation. Specifically, we've leveraged the MapReduce approach to simulate worm propagation via the technique illustrated here. Infected nodes indicate new targets during mapping, and these attacks are resolved during reduction. Unfortunately, since each node emits at least itself during the mapping phase, the intermediate shuffle turns out to be very, very expensive. Accordingly, our simulation results are satisfactory, but lackluster. To address this performance bottleneck, we utilized the shimmy pattern to avoid the expensive intermediate shuffle. The shimmy pattern emits only modified elements during mapping and shuttles static data to reducers via partition files. Now this requires good communication with the HDFS for delivering these partitions, and of course we'll need a custom Hadoop partitioner. The application of this pattern yielded good performance improvements over our naive approach, and our simulation approach offers some attractive qualities over existing formulaic methods. So let's look at a demo on a very small network. Here we'll utilize a 256 node universe, define a propagation delay of 10 milliseconds, and run for 75 iterations. And here we have a visualization of our results. Black nodes represent infected machines, while yellow nodes are vulnerable to infection. This has been Internet Worm Simulation using MapReduce. My name is Brandon Haynes, and on behalf of Charles Lee, thanks for listening.